Okay, this is the second video for chapter 13.5. The next question asks us to find the area under a curve of the function. So when you want to find the area of the curve, you basically need to find the definite integral, right? So this is from two numbers, from a number to another number, so it's definite. And then finding area under the curve is trying to find the definite integral. And the other word for integral is what? Antiderivative. Alright, so let's go ahead and do it. So the integral is from the lower limit of -1 to 2. This is x squared plus, minus 2x plus 2 dx. Does it need to do substitution? Does it have a chain here? We don't, right? So that's awesome. So we can go ahead and take the integral. The first one would be 1 over 2 plus 1 is 3 x cubed minus 2, and then this basically become 1 over 1 plus 1 is 2, and then x to the second power, and then plus the 2, you add an x back, right? So after we take the integral, we can plug in the upper lower limits, right? Okay, so now let's go ahead and do it. Let's clean that up. So this can reduce, right? So this is basically 1/3 x cubed minus x squared plus 2x, and then we can plug it in to -1. Alright, so plug in the upper limits, subtracting the lower limits, right? Cube minus something squared plus 2 times something minus the second part is 1/3. Plug in the lower limit. Okay. So the first set we plug in the upper limit and then lower limits. Alright. So the first fractions will become 2 cubed is 8 over 3 minus 4 plus 4, okay. And then subtracting, this is still negative 1/3, and then minus, this is still this is 1, and then minus a 2, okay. So we got an 8 here, 4, and then another 4. This would be the -1 from there, and the 1 and the minus 2. Okay. Alright, so let's see. I can get rid of the parentheses. Okay, now this is gone. This add this is going to be 9 over 3, and then plus these two together is adding 3. So basically 3 plus 3 equal to 6 units square. They didn't tell what units it is, but this is for the area, right? So if you need to find the area under the curve, you take integral and they give you the limits. You apply it. That's it. Alright, one more topic for this section on the last page. The last topic is going to be the average value of a function. So average value of a function, the average value of a function between an interval a and b is going to be like this: 1 over b minus a, and then take the integral with those as your limits. So on the test, I may have one question ask you to find the average value, and the formula will be given to you, so make sure you apply it correctly. Average value of the function. So I just have a very basic function here, and then this is the integral. Interval, sorry. It's going to be from a to b, right? So because they asked for the average value, we're going to use that formula, right? 1 over b minus a, taking integral a to b function, right? dx. So we're going to plug it in. We're going to have 1 over 2 minus a negative 1, right? And then the integral is from negative 1 to 2. And then we need to plug into that function x squared plus 2x minus 3 dx, right? Sorry, I went out of room a little bit. But then we can see this is 1 over 2 plus 1, basically. And then I can start taking the integral, right? So this would be 1 over 3x to the third power. Just be careful, sometimes people will switch back to taking in the derivative. Plus 2 times 1 over 2x squared, right? And then minus the 3x, and after that we need to plug into the limits, which is negative 1 to 2, right? Let's clean that up slightly. We got 1/3, this is 1/3 x cubed plus x squared minus 3x, and then we are ready to plug in the limits. Alright. So we're gonna leave the 1/3 outside for a while, just hang there, and then we can have 1/3 something cubed plus something squared minus 3 times something, and over here we'll subtract the second part, 1/3 something cubed plus something squared minus 3 times something, right? Alright, so the upper limit is like 2. And the lower limit is negative 1. Alright, let's see. So we got 1/3. This is 8 over 3 plus 4 minus 6 minus negative 1/3 plus 1 plus 3, right? Okay, now we need to do some combining. 1/3, this is 8 over 3 plus 4 minus 6 plus 1/3 minus 1 minus 3. Alright, let's see what can we combine. So again, this and this together is 9 over 3. Okay, 4 minus 6 is negative 2 minus 1, negative 3, minus 3, negative 6, right? Minus 6. So this is 1/3. This is 3 minus 6, right? So we got 1/3 times negative 3. So basically this is just negative 1. This is the average value of the function. Okay, so not particularly difficult, but you need to read the question carefully and just apply the formula. Alright, and then we have 2 application problem. I will have this file online, so I know it's not very clear. Okay, so let's look at number 69. A cost function, let me see. Cost, a company by manufacture mountain bike. The research department produced the marginal cost function. So this is a marginal cost with the apostrophe here. So it's already taken the derivative, right? This is a marginal cost function. Okay, so where c pi of x is in dollars and x is the number of bike produced per month. Compute the increase in cost going from a production level from 300 bike to 900 bytes per month. Set up the definite integral to evaluate it. So that's the lower and upper limits, right? So they told us to do the integral, so we're going to do that. Let's see, let me get a piece of paper. So this is number 69. Okay. 69, and then they asked us to take the integral from 300 baik to 900 baik using the marginal cost functions. And then after you do that, you will get the cost function, right? Okay, so let's start 900, 300. The function was 500 minus 1/3 x, right? dx. Okay, so this one we don't really have to do a chain rule, right? There's no function raised to a power. So we can go ahead and try to take the integral. This will become 500x minus 1/3, and the x will become 1/2 times x squared, right? Okay, so, and then don't forget my limit is from 300 to 900, okay? So this is 500x minus 1/6 x squared, right? And then we have 900 here and 300 here. Alright, so now we can plug it in with the upper limit, subtracting the lower limit. Okay, so the first one we plug in 900, and then 900, and then this would be 300 and 300. Alright, so that will give me, you can use the calculator. Let me double check on my steps. You should get 180,000, which means the increase in cost from producing 300 bytes per month to 900 bytes per month is 180,000 per month. So that's a lot. Hopefully they make a good profit for that. We don't know. Alright, so that's number 69. We have one more question, okay? So the last question is number 78. So number 78 say average cost. The total cost in dollars of printing X dictionary, they give you a cost function. Find the average cost per units if 1,000 dictionary were produced. And then they want you to find the average value of the cost function. So be careful with this. Like, remember we have that formula to find the average values of something over the interval of 0 to 1,000. Discuss the difference between A and B. So let's start with A. Okay, so you are given a cost function and you need to find the average cost function, right? So hopefully everybody know what to do with that. Number 78, given your cost function, C of x equal to 20,000 plus 10x. So find the average cost function. Basically, C bar of x equal to C of x divided by x, right? So all I need to do is divide every term by x. So 20,000 plus 10x divided by x. So my average cost function is 20,000 divided by x plus 10, right? So that's my average cost function. And then they want to know the average cost if 1,000 dictionary is produced. So the A part say x equal to 1,000. So CY of 1,000 will equal to 20,000 divided by 1,000 plus the 10, right? So basically it's 20 plus 10, which means $30. So this is $30 per unit is the average cost if 1,000 units is produced. This is $30 per dictionary. Is the average cost if 1,000 units were produced. I have a hard time writing. Okay, so that's the A part. It costs $30 per unit if you produce 1,000 dictionary. So the B part, say they want to find the average value of the cost function. So average values, of the cost function. So first of all, we have that formula, right, which is 1 over b minus a. From lower to upper, take integral of the function, right? And they want that function to be the cost function, okay? So, and this is between, they want 0 to 1,000 units. Okay, so let's plug it in. We got 1 over, your upper limit is 1,000, the lower limit is 0, right? And then 0 to 1,000, take integral of the cost function, which is 20,000 plus 10x dx. Alright, so I think we're ready to take the integral. This is 1 over 1,000, and taking integral, that would be 20,000 x plus 10 times 1/2 x squared, right? And that would be from 0 to 1,000. So clean that up. 1 over 1,000. This is 20,000 x plus basically 5 x squared, right? I think we are ready to plug it in. And I especially like the second part is 0, so everything will turn into 0, so it's perfect. Okay, now 1 over 1,000, this is 20,000 times 1,000 plus 5 times 1,000 square, and then minus, basically the first term times 0 is 0, the second term times 0 is 0, so you're just subtracting 0 for the second part, right? Okay, now this is 1 over 1,000. This is a big number, so let's see. 20,000 times 1,000 plus 5 times 1,000 square. Whoa. So it's going to be 250,000,000. 2460, 246. Okay, and then I need to divide by 1,000, right? So divide by 1,000, I still have $25,000. So how is the difference between this guy and the first answer we have? So this one means the average value of the cost function over 0 to 1,000 units is $25,000. So what does that mean? because the C part say we have to figure out what's the difference between the answer you found from A and B. Okay, so C part say from A we got C bar of 1000 is the average cost per unit at production level of 1000 units. And then for from B, it figure out the average value of the functions for the total. This like one is average cost per unit, this is total cost as production increase from 0 to 8,000 units. So one is like cost per units for the average cost, and the average value mean the total cost for the production between 0 to 1,000 units. So alright.